So, good afternoon, third semester plastics technology students of Choturam Polytechnic Rohtak. See, students, till now I have discussed with you the two issues, namely, first one was your additives and blend, their definition, and then their types we discussed. Later on, we diverted our focus and I discussed with you conducting plastics. So now the in continuation of your alloys and blends, I'll take this lecture and one more after this. In that particular lecture, I will discuss with you some examples of additives and blends. Right now, we will go for the methods of blend formation. What are the various methods? So, see students, there are five methods using which we can blend the two polymers, and then the you can say, okay, what is blend? It is a mix of two or more than two polymers or copolymers. So there are five methods using which we can mix two polymers or copolymers to make a blend. So first method is mechanical mixing. So I will try to write here. So students, the first method is your mechanical mechanical mixing. Mechanical mixing. See students, this I have written you for your, it is the name of the method, that is mechanical mixing. It is also called, sometimes it is also called melt mixing. So melt mixing and mechanical mixing, they are one and the same processing methods to make additives and blends. You can name this method as a melt mixing or mechanical mixing. Now what is this process, students? As you are the students of fourth semester, you have studied the extrusion. So we classified extruder using different classification methods. Among them, one was single screw extruder and multiple screw extruder. Then next to this multiple screw extruder, there were two type of extruders. Two screw extruder was there, and I told you that four screw extruder is also there. Four screw extruder is also used, but very rarely. The maximum processing is completed by using twin screw extruder. This twin screw extruder is further classified as co-current type and co-rotating and counter-rotating type. So what is co-rotating screw extruder? In which both the two screws rotate in the same direction. Then it is called co-rotating screw. And what is counter-rotating screw? In which the one screw rotates in a clockwise direction and the one rotates in a anti-clockwise direction. And there I taught you that when you have to blend something, because other than the one application of extrusion is to make the various products. There are number of applications of extrusion which I taught you. I am not going to discuss them. But films, sheets, pipes, rods, other profiles, and blown film, all these processes, even blow molding, all these processes have a basic extrusion. All these are the applications of a process called extrusion process. And when I taught you twin screw extruder, then I taught you that when we have to mix, because the other application of extruders was to make a mix, to mix the various entities, and out of those entities one entity is making blend. These extruders, twin screw extruders, can also be used to make blends, and out of these two, means co-rotating and counter-rotating, I taught you that when you have to mix two entities, then it is advisable to go for co-rotating type of screw, and when you want high output, then it is better to go for counter-rotating screw. So co-rotating twin screw extruders are used for making blends. So the method is very simple. What we do is, students, first we mix the two materials. Suppose two materials are there and we have to make a blend out of them. They are available in granule form. Then the first method will be to mix them in a ribbon blender or in a high speed mixer. You will mix them and then you will transfer this blend into the hopper of the extruder, and then normal extrusion process will take place. What is extruder, you know very well, so that is not a part of our discussion right now. I will take some other lecture to elaborate you the extrusion process. So you transfer or you pour them in a hopper, and from hopper it passes from the feed zone to the compression zone and then to the metering zone, and while they pass through these zones, they are also exposed to different temperatures, and internal heat generation is there, also external heat input is there. So under the influence of this heat and mechanical work, these two materials, they get mixed and the blend comes out in the form of a melt, and that melt we may use for any of your applications. So that is one method of mechanical mixing method of making blends, or melt mixing method of making blends. In the second method, you can use two roll mill. It is another method by using which you can make a blend. Now what is two roll mill? This is again a very important you can say machine which is used. It is a mixing device. It is a machine which is used to make the blend. Now what is this two roll mill? See students, this two roll mill is built up of two hollow cylinders, or sometimes solid cylinders also, and these are very highly plated, nickel plated and highly polished. Two rolls are there, cylindrical rolls, which rotate in the opposite direction, and they are heated cylinders. They can be heated by using electrical means by using cartridge heaters, or they can be heated by using your heated oils. In the case of oil heating, they are hollow, means they are hollow from inside, and in that space we transfer the hot oil, and that hot oil transfers your heat to the material to be mixed. So if I see the process, what is that process? Actually one roll is like this, and other roll is like So students, in that two roll mill, you have one roll like this, it is a roll, and another roll like this, and there is a gap. Here I have made more gap, but this gap is very less. This is called nip, and these are not circles, these are cylinders. I am showing you the cross section view, and these are highly polished cylinders, and they rotate in a counter direction to each other like this. And what we do, they are heated also, either they are heated electrically or they are heated by using hydraulic oils. And what you will do, This is this is the figure where the nip is much high. You won't be able to understand. So I'll make another figure. So it is your one roll, and then it is your another roll, and they rotate in a counter traction. What you do is you pour the materials here, one material, and then I'll change the color so that then the another material, like this. Two materials are there, and you operate them in a counter direction to each other, these cylinders. What will happen when they will move in the opposite direction? The material will get squeezed in between these two cylinders, and when the material gets squeezed means all type of forces are being acting on the material, the raw material. Means you talk about any force: tensile force, compressive force, flexural force. All type of forces are acting on this material: tensile, compressive, flexural, and if some shear, tear, wear, every type of force is acting on these materials. And under this influence, what will happen? See students, normally it is a batch process, but sometimes it is used in a continuous operation also. In that continuous operation, what we use is, okay, here we have two rolls, and beneath these two rolls we will have a set of again two more rolls. But what these rolls are these nip is between in a straight line. It is not like that, okay, two rolls are here and two rolls are here. Nip is in straight line, but what happens is, okay, this here the nip gap is more, the here, and here the nip gap is less, and one set of still one more set of rolls will be there beneath these second set of rolls. Beneath this second set of rolls there may be third set of rolls also, then fourth set of rolls also. Their nip will keep on decreasing as we will move down from the top most two roll mill. As we will move from the top of the two roll mill towards the bottom, and still the third one and then fourth one, the nip goes on decreasing, and in this way the process is more or less, it is continuous. But normally these two roll mills are used in a not in a continuous way, but it is a batch type process. So what will happen? See, you have these two, again I will draw these two rollers are there. One is here and one is here. See students, and then you are using two type of material. One is like this, one is this here, and the another one here. In the granular form you have material, these rotate like this, and material will get squeezed, and it will below this there is a you can say tray wherein this partially melt material will get collected. So after one set of rotation, partial mixing will take place of these two materials. They will deform, you can say, like this, and the other color is this. So see, the partial mixing will be there. Then what we will do, see, this portion is not there, sorry, and from here the operator will collect this, and then he will adjust the nip and again pour this partially melt material here. Here he will pour, and again the same operation will take place. He will keep on collecting the material which is falls down downward side on the tray, and after 3-4 steps you will get something like this. See, here it is one roll. Now you know the gap will be very less here. They are rotating, and now you have a I will say mix now, like this blend, and this blend with what will happen, this will stick to one of the rolls here, and then you will remove it. Now this blend has been formed. Now you may ask, and you should ask, that why the this blend which has made using two roll mill has stick to this roll only. See students, this might have stick to that also. This we can control. To which roll your melt will stick, that can be controlled. How? By varying either the temperature, we will keep the temperature of this roll a bit high, or by changing the speed, we will keep the speed of this roll a bit higher than this roll, or both. By controlling the speed and temperature, we can make that this blend which has formed will stick to a roller which is on the side of operator, and from there the operator will remove this blend, and afterward we can use it again. We can granulate it, and we can use it where we want to use it. It can be injection molded, even it can be extruded, or whatsoever technique. This can be if you are going to make samples out of it, you can compression mold the thermoplastic. Any process you can use, and in this way the blend has been formed. This is the second method. The first one, the extrusion method, that was a continuous method, and this two roll mill method, this is a batch type operation in which the blend is formed, and later on you use this blend wherever you want. So students, these were the two methods which are used to make blends, and they are called melt mixing methods, or which are called mechanical mixing method of making the blends. Now we will go to the second part, and that method of mixing is called solvent mixing. What that method is called? That method is called solvent mixing. Solvent, SOLVENT. Solvent mixing. So here, as the process is saying, solvent means whenever you are using solvent, means what? You are making a solution. So what is solution? It is a mix of solvent and a solute, wherein solvent is present in excess and solute is present in the lesser extent, in the minor extent, and the solvent is present in excess. So what we do is, students, suppose we have got two polymers, A and B. We will choose two polymers such that they are soluble in a common solvent, and it is not a very difficult method. You can easily have two polymers which have a common solvent. So you will use a common solvent, and you will make a solution, two solutions using A and solvent. Suppose solvent is X, you will dissolve A in solvent X, and then in a separate you will use B and dissolve in solvent X, and then you will mix these two. Or if the enthalpy and our other things are same, then simultaneously you can do this. So the solution will be formed, and what we'll do in this way, now your blend has been formed, and this method is called solvent mixing method. And here what we do is, later on when the mix has been formed, we evaporate this solvent. And only this blend A plus B is left, and in this way our blend or alloy forms. So this is a rather this method, it don't requires much of the elaboration. It is simple. You make a solution using two solutes and one common solvent, and then you evaporate the solvent, and you will left out with the blend. So this method is called solvent method, or this method is also called dissolution in co-solvent, means commonly it is called solvent mixing method. Now we will go to the third method, which is called latex blending. So latex blending. The third method, students, is the latex blending. LATEX and then blending. Now first you should be clear what is the meaning of latex. So students, latex is a homogeneous colloidal dispersion of polymer particle in water. It is a homogeneous colloidal dispersion of polymer particle in water. See, it is slightly different than solution. Means solution is a homogeneous in nature. In the latex, what we have a solvent, say water, and in that water you have tiny droplets which have been suspended of the polymer. Then you will get a latex. See, milk is a colloidal solution, you can say. Milk is also a colloidal solution in which in the solvent those butter molecules are suspended, but they are not separated easily, or they will not set under the influence of gravity. They won't set. See, if you have some other solvent and solute system which is not latex, then what will happen? If you will keep that colloid, that first thing, that won't be colloid, that will be a suspension or something like that. So that solute will get settled down under the influence of gravity. But in the case of latex, that's a suspended part, whether that is a polymer suspended in a solvent, that won't settle down. So that is the definition of your latex. So this method is used wherein the two polymers are capable of making a latex with a solvent. So rest of the process is same. What we do is we will use polymer A. We will take polymer A, suspend it, make a colloidal solution of it, we will make a latex of it. Suppose that is capable of, like PVC is capable of making latex with your various plasticizers. Various plasticizers like dioxyphthalate is there, DIDP is there. Number of plasticizers are there which when you use them in excess, so plastisol called, that is a latex type solution that is capable of formation. Similarly, there are other polymers also which make latex. So what we do is we first make latex of these two polymers and then we mix this latex, and later on what we do is we dry this whole A plus B latex which you have made. You dry this solvent from this latex, or you use the coagulation technique, wherein these A and B, they will get separated by phase separation process. You can use a coagulation or some precipitation may be used. So using that coagulation you can separate A plus B blend from the solvent. So that this process is called latex blending. It is something same as solvent blending, the only difference in the solution and in the latex. Some polymers, they are not capable of forming solution. They don't have a common solvent, or a variety of conditions are there because we have a large number of blends. So one technique is not sufficient for making them. So we have to look for the other techniques also, newer and newer techniques. So this process is called your latex blending technique. The next process which students is of importance is fine powder mixing. See students, I will say this process to be a process of primary process of making your blends. Means it is not the final process, because powders either, see, first I will write the process. It is fine powder mixing. Fine, it is fine, then powder, like the thermosets powder, it is powder mixing. So you know there are certain thermosets, normally they are in the form of dry powders, they are available. Then PVC is available in the dry powder, or you can make a dry powder of any thermoplastic. There is no problem. Pulverizing technique can be used to make powder for with any polymer. So when you have two polymers in the form of powder, then you will mix them, or later on you may use some solvent mixing or some other process, or means as a powder, I don't think they have of much importance, because to make a blend, that dry powder will be sufficient, or might be, but when we define process, because see, after blending you have to process. So melt deformation, deformation in rubbery state, or deformation of a solution, or deformation of a suspension, or machining operations. All these techniques were there for processing. So in all of the techniques, there is nothing like powder which is used. So when you have means you can use high speed mixer or ribbon blenders. Now what is high speed mixer, students? You can use high speed mixer. It is a mixer like this. And normally this method is used to compound PVC. And here on the bottom you have blades which are capable of rotating at high speed. So what we do is, two powders are there. One powder is like this, dispersed here in the form of fine powder. Then you have the another powder like this, dispersed here. See, two polymers are there. There can be three also, no problem. What is there? Four also. So like this. And what you will do, this is attached to a motor, and that motor rotates it at a high speed. So when it will rotate, so two things will happen. What? Number one, these polymers which have been shown in green and blue color, they will get mixed, and a uniform, you can say, dispersion will take place, and a blend will be formed. And secondly, because of friction, their temperature will also increase, and as a result of this friction, they will also get preheated. And later on, you will have to use either extruders or two-roll mill or something, extruders commonly, to make a melt out of them, and then you will use. Or you can directly use them in extruder to give the product. Now there is no need to make the melt, right, which we used in the very first process. So in this way you can use. So this process is called fine powder mixing process. And now students, we will move to the next very important process. And what is that process, students? That is the third process of making your blends, and that process is called IPN. It is IPN. Now what is the meaning of I, what is the meaning of P, and what is the meaning of N? See students, it is interpenetrating polymer networks. This is a very important technique, because this technique uses the molecular levels of the polymer. This technique uses the polymer levels of the molecular level of the polymer. So that is why this technique is very useful. Now what is IPN? First, what is this interpenetrating polymer network? Let me tell you students, the word we have used here is network. And with plastics, this word is used, this network word is used when the plastic, whether it is a thermoset or it is a thermoplastic, it is in the cross-linked form. When it is in the cross-linked form, then only we use this word networking. So it is interpenetrating polymer network. Now what is this IPN? What is the meaning of interpenetrating polymer network? See students, IPN is a polymer comprising of two or more networks which are at least partially interlaced with each other on a polymer scale, or you can say a molecular level, but they are not covalently bonded to each other, because in all the polymers, when you make a polymer from a monomer, the bond which involves is a covalent bond. But here we already have two. There are that we will discuss further, the types of IPNs. But here, one network is there, and the second network is there. They are intermingled, they are interlaced. But those networks, suppose if I want to say, I'll suppose see, okay, first it is a network. So what is network? See, it is a thermoplastic. Network means cross-linking means like this. Now cross links are there. Now what is IPN? It is a polymer comprising of two or more networks. So means what? We have another also. Okay, students? So we have another network present here, like here, like this. Now these networks are intermingled, interlaced with each other, but they are not covalently bonded. The covalent bond is between individual polymer networks, and but not with the two corresponding, means with the polymer which I have shown you in the blue line and the one which I have shown you in the green line. They are not covalently bonded with each other, but no doubt they are intermingled or interlaced with each other. So resulting melt which will be formed, or sorry, not melt, resulting blend which will be formed, that will have a very good properties, mechanical and other also. So this is called IPN, interpenetrating polymer network. Now further, there are methods of making IPNs. So you can say that by the virtue of making the taking in account these methods, we have classified these IPNs. And how we have classified? Three type of IPNs are there. What are those? First one is your sequential IPN. First classification. First, now it will be a bit difficult, but I will try to write it. So first one is your SEQUENTIAL. Sequential IPN means, later on I will tell you how it is formed, what is the meaning of sequential IPN. So second one is your simultaneous IPNs. What are those? Those are, I will name them, they are simultaneous IPNs. Simultaneous. This is the another type of IPN. See students, first one was sequential, now this is simultaneous, and still one more is there, and that is called semi or pseudo IPN. What is that? That is semi. I will give you difference between semi and pseudo also. Semi IPN, or another name you can say pseudo, PSEUDO, pseudo IPN. See students, as per the method of I will say synthesis, by using as we use the different methods of synthesization for these IPN, we have classified them as sequential IPN, then secondly simultaneous IPN, and third one was your semi or pseudo IPN. So we will discuss them one by one. I will try to give the figure of them also. So first one is sequential, as it is well known. What we do is we will take one monomer, first monomer, say we will take first monomer, and that monomer is A. See students, then to this monomer we will add initiator. Initiator, as you know from the knowledge of your polymer science, and to that you will add the cross-linking agent. Cross-linking agent, this you know from the knowledge of thermosets, LINKING. So you will take these three things. The first moiety is your monomer, then to that benzoyl peroxide or anything like that, then some cross-linking agents are there. A number of cross-linking agents are there. Right now you just concentrate here that cross-linking agents are there. So you will add cross-linking agent, and what you will do, you will polymerize this. You will polymerize this, and in this way what will happen, you will get a network which is made up of polymer A, like this. You will have a network. This is your polymer network. Here you have cross-linking and a network has been formed like this. In this way you have a polymer network which is made up of your monomer A. Now it is sequential. Now what you will do, you will dissolve this polymer network made up of polymer A in a monomer B. See students, I will take a green color for this. So what you will do, you will dissolve this in a monomer B. You will use a monomer as well as initiator and then cross-linking agent. For monomer B, you will dissolve this polymer which has been formed in the monomer B. Now you will polymerize this B which is given in this green color. So when you will polymerize this, what will happen? Like this, like this, and then there will be, because of your cross-linking agent, there will be cross-links of B, and now these cross-links have intermingled with each other, A and B. Now they are not covalently bonded, that the polymer which I have given you in color B and the polymer which I have given you in color A, they are not bonded, you know, with a covalent bond, but they have get mingled. You have one polymer, you dissolve that polymer in polymer B, and then you polymerize. Means what? I will try to show. See, my one hand is giving one polymer network, then you dissolve it in the solvent, and then you polymerize that solvent. Now this type of bonding will take place, intermingling. No covalent bonding is there between green and red polymers, but intermingling is there. So in this way you will get a internet IPN, interpenetrating polymer network. This is called simultaneous. The second one, which is called simultaneous, it is sequential polymer network. Now we will go to B, which is your simultaneous. As the word is suggesting, it is simultaneous, means simultaneously polymerization will take place. Now you will say, okay, what is the difference between then co-polymerization and IPN, simultaneous of IPN? See students, first of all, the first difference is, here we are talking about networks, means we are adding a cross-linking agent. Normally in copolymers, when we make using addition or any other technique, when we make copolymers, we don't use cross-linking agents. Here we are using cross-linking agent. But even then, see students, your question is right, which you may ask. Even then we have to opt for the two polymers of whose polymerization do not interact with each other. Means the polymerization of the two polymers, it should not interact with each other, otherwise there is a very good possibility that this definitely this network will form, but there is a very good chances that a copolymer will also form as well. So it is better to choose a system such that I will try to first make it. So it is better to choose a system such that one polymer is made by condensation polymerization process, and then the other polymer is made by free radical addition polymerization process. If you will choose the monomers like this, one is capable of forming polymer with the help of condensation polymerization, and the another is capable of forming polymer with the help of addition polymerization, then this type of the possibility of developing a side product of copolymer is totally ruled out. See students, so it is like that. Or if you have to use both as addition polymers, even then you can go for that, but then you will have to make selection accordingly of the monomers, and even then after making the selections, best possible selection, even then the possibility of copolymerization cannot be ruled out. So here let me tell you students, first see here, these are the various monomers of which will form a polymer A, you can say. These are the various monomers of polymer A, and then you have various monomers. See, if it is a condensation, so then definitely two entities will be shown here. So right now we assume it to be both of them to be made by addition polymerization, otherwise I will have to add a third color in this figure. So you leave it, you think these green colors are two different entities if it is a condensation polymerization. You are a student of very good caliber, you will simply understand this figure. And students, so later on what will happen, see, this will like this and like this and like this and like this, a cross link will be formed with these monomers like this, like this, like this, and like this. See, once the monomer has simultaneously, means I am not able because this screen don't allow me to make the polymers of both the monomers to make allow the synthesis by my finger. I cannot synthesize both the monomers simultaneously. So the second is in red color. So simultaneously what will happen? This red, this, like this. Now they will cross link like this, and simultaneously this is happening. It is not sequential. Simultaneously means you used and then you see a cross link has been formed. So like this, the formation of this type of blend, the IPN, that is called simultaneous IPN, interpenetrating polymer network. Now you can say, okay, what is the use? When we were having one, again same question, sequential is there, sequential technique is there, then what is the need of this simultaneous? See students, okay, with the passage of time, it has been seen, because the polymer networks which are made with your sequential technique, number one, two reactions are required. Means first you will have to polymerize the monomer A, then you will dissolve this polymer which is made up of monomer A into a monomer B, and then you will start a second reaction. So two reactions are required. So you have to control two reactions. So that make a process bit you know, more time consuming also and typical also, and definitely when two reactions are there, costs are there. And in this process, when you are using simultaneous, then you need only one reaction. One reactor vessel is there, and in that reactor vessel you are adding both the monomer entities and then simultaneously. So this is the one difference. The other difference is because these are cross linked, so normally they are processed by compression molding, but by using simultaneous cross linking this IPNs simultaneous, we are capable of forming certain IPNs which can be extruded. So this is the second application of this your simultaneous IPN, synthesis of IPN. Now we will go to students third type of IPN, and that is called semi or pseudo IPN. So what is this? Students, it is very simple. Here in this case what we have is, see students, what we have is that one polymer has a network structure and the other polymer has a linear structure, and they can be made by both of techniques, like means, see, definitely two monomers are there. With one monomer you are using a cross-linking agent and you are making it to cross-link, but with the second monomer you will only allow it to polymerize and you will not allow it to cross-link. So you can use the sequential technique or you can use the simultaneous technique. So if you use a sequential technique, means what you will do, first you will make one network, then you will dissolve this network into another monomer, and then you will polymerize that another monomer, but you won't allow that say a monomer A has been cross-linked, but you dissolve this into B, but you don't allow B to get cross-linked, but simply you will make a linear polymer. You will polymerize monomer B to make a polymer, but not cross-link. So if you use sequential technique, then this is called semi-IPN. And if you use simultaneous technique, means you are using two monomers, monomer A and monomer B, out of which monomer A has been cross-linked to make a network structure, but monomer B has been allowed to make a linear structure only, then this is called pseudo-IPN. See students, so I will try to give you the, say this is your polymer A, it is cross-linked here like this. See student, it is cross-linked. Now what you will do, you will add entity, say in the green color, B, it is like this. These are the dissolution. Now you have dissolved this IPN, and it is not IPN, but definitely it is polymer network is there, but interpenetration has not taken place still. Now you have dissolved this polymer network into monomer B, and now this will not cross-link B, it will make a linear polymer. How? Like this only. One chain is formed like here, one like here, one like here, 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 and here, like this. Now see, the polymer which is formed in green color, that has not been cross-linked. See, this is the difference. In the previous two techniques, both of the monomers which you added, they were cross-linked either sequentially or simultaneously. But whether sequentially or simultaneously, you won't allow one polymer to cross-link. That will simply polymerize and one polymer will cross-link, and in this way you will use the technique and make a IPN called semi or pseudo IPN. Students, I think it is quite clear to you. Now it again has advantages. If you know you increase this linear polymer, content of linear polymer in this IPN, I have already told you that normally these IPNs are used with compression molding. They are, because cross linking is there, and that is why they are not able to
be used in the injection molding or these extrusion techniques. But if you increase the content of linearity here, means if you increase the concentration of B in this particular technique, so you will get a polymer network which can be used with the these techniques like injection molding and extrusion. Means you can process these IPNs like other thermoplastics. So that is the advantage of semi IPN. So students, this was about the methods of manufacturing your blends and alloys. If you have any query, you can send me through your WhatsApp group. I will solve them and I will send you back. For now, thanks. Good night.